you know what? I should check and see. Oh, nope. All right. Well, in that case, we are streaming. Hooray. Looks like we are live on Twitch. I'll go ahead and tell the world. Do, 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 do. All right. And we're here. Okay, hooray. So today we are going to just do more stuff. I'm not sure what yet. We've been kind of working through the pieces that we need, but we haven't really started to put anything besides the fundamentals together. That initial little bloop is something I want to get rid of, so let's get rid of it. The way we're going to get rid of it is we're going to remove this. We don't want that to be there. So instead we're going to set this fade to black speed to a hobojillion. And that's going to be our default entry state. My bad. And that should instantly cement it as a pitch black element. No, it still did the fade to black. Oh, because it's the very, very first. So the thing here is that this is the very, very first time, and we immediately try and fade to black, but we're okay trying to figure this out. And fundamentally the problem is that this fade to black is what we transition into, and it starts with it being unfaded to black, right? Well, there are a couple of ways to do it, none of which are particularly good. We'll deal with it later. I'll think of something. So I've been working on tabletop RPGs recently, and that's been a lot of fun to come up with cool rules for tabletop RPGs that make them feel like maybe video games they're based on. So I've created, or movies. So I've polished up my old Star Wars stuff, but I've also created some for Mass Effect, and that's a lot of fun. And it's a lot easier than developing computer games because the piecemeal pieces fall together. Whereas with computer games, you need to have everything working before anything can work. With that said, I think that it might be time to figure out whether or not we want. What is that? That's a flaw in the skybox generator. So that's a seam in the skybox, which isn't great. I'll probably have to come up with another way to do skyboxes because this one is turning out to not be fantastic. Anyway, what we've got right now is this setup here where we can take a look at our ship, and you can see how high this is. There's a lot of space above our ship. What I'm thinking is that when we decide that we are going to open up one of these tabs here, what we'll do is we will change the camera to be a more aggressive camera for looking at the center of the ship. Because if we look at the camera right now, what we've got is this main camera gimbal, which is nice that they're in the middle of the ship, right? So why isn't the camera looking at the ship? And the answer is that the camera is not ever moved. The camera at the moment is just looking straight ahead. See? 0, 0, 0, 0. And the offsets, they look like they exist, but it's just a Z offset backwards because I zoomed it, right? The camera animation mount, however, has moved considerably upwards. You can see that. So what I'm thinking is that what we might do is have a couple of, I don't know, static overrides might be a good idea. Basically, we can't animate this. If I unpause this and then I try and animate this, it works. Okay, so my idea here is that it might be that the animation playing right now isn't actually animating the camera animation mount, but it will. If we look over here in the main cam gimbal, you can see that if I try and change this, it just pops right back to where it was because the main camera is being animated, and that's one of the things that's being animated. So what I think I'm going to do is create an empty animation and just transition over to it. I don't know whether that's going to work. There are a lot of things that could be annoying about it if it, if it decides to be. So we're just going to call this SO null. And SO null is going to be another one of these animations that doesn't actually animate any of the things we care about. So what we're going to do is we're going to grab this ship gimbal and we're going to just set the scale to 1. Oh, I forgot to actually hit record. There we are. So now that that's set to 1, it's going to be trying to set the scale rather than anything else. Now the question is, when we play this animation, is it going to end up reverting all of the other settings, or will it leave them in the same place? And I honestly can't remember. It's been a while since I've had to do anything like this. So if we wanted to get this to work, here is the SO null, and you can see that it's on the wrong panel. So we're going to just switch over to the other layer, paste that in. That's not the right one. There we are. SO null. Yeah, there we go. And we're going to go and make this so it doesn't loop. There's no reason for it to loop. And what we're going to have is this is going to come out at the end of its exit time, like so. And we're going to play it and see what happens. Okay, so right now the main cam gimbal is not freed. That's interesting. So if we look over into the animator, SO null is the one playing. It's done playing, right? But why is it preventing us from moving the main cam gimbal? The main cam gimbal doesn't have any X or Y or Z position modifiers. All it's got is a scale modifier, and the scale modifier works. What the heck? Hold on, did I screw up the animation? Ship gimbal scale. So this is the only thing the animation is supposed to do. It's supposed to set this scale. But here in the animator, when it actually plays, for some reason it doesn't seem to be playing correctly. So we're going to just take another look here and see whether or not we can debug this a little bit. There's something funky going on. So here it is playing through the camera long zoom, like so, and then it's supposed to pop over to the SO null, and that's exactly what it does. So now that the SO null has been played, in theory this main cam gimbal can be moved, but it can't be. Moreover, the scale can be changed, which makes no sense because that's the one thing that should be being animated. What is going on? So one of the other things I can do is I can make this player-controlled gimbal have a Z offset that brings the ship, or Y offset that brings the ship back into the center, just by setting it to have the opposite Y offset of this, right? If this is negative 0.97, then the player-controlled gimbal would be 0.97. But it shouldn't be necessary. I should be able to animate the main cam gimbal. What am I missing? What have I forgotten about? Let's turn on looping and see whether that changes anything. So here it is getting played. Here's the main cam gimbal. We're zooming in. You can see how these values are all changing. That's fine. And then, no, it's not working. But this is still... Is it because there's no changes that it's doing this strange thing where it refuses to actually have anything happen? Do I need to have it? Well, let's just try making it change the scale a tiny bit and then right back again, just to see whether or not there is like the tiniest difference, and that'll be enough. Let's just find out. So we should see this blip. Blip. So there you can see it. So now if I try and change the scale, it's not budging. It's sticking. And if I try and change the rotation and the position, it works fine. Okay, so the problem was that because it didn't have any actual animation elements in it, it was refusing to animate. which is fine, except for it should have refused to animate in a way that didn't keep animating the old animation. I think there's a bug in Unity where it won't update the animation mask unless the new animation has actual animation. The downside of that is that I don't want this to actually scale anything. What I want it to do is nothing. So I guess what I can do is I can make this scale it in the smallest possible measure. Let's just take a quick little look here. If we bring this back down to like 1.0000001, it goes down to 1. If I make it that small, it's going to end up. So I think that'll be okay. I don't think we'll ever be able to see that particular wobble. We'll find out. Because the other thing I can do is I can make it like a handy cam sort of thing, where it wobbles in a way where it just feels a little bit natural. But I don't think there's any reason for that. Anyway, the next step is that when we are going to be... Oh, that's the ship gimbal. This is the main cam gimbal. The problem is I'm a friggin' idiot. Okay, sorry everybody, that was just me being stupid. I animated the wrong thing. But it still shouldn't have... Well, whatever. So what we're going to want to do is we're going to want to take this main cam gimbal and do that. I knew it was something obvious that I didn't understand. I just didn't think it was something that I'd have to be a brain-dead idiot to not understand. Alright, so now we're going to go ahead and try that. And we're going to see whether the main cam gimbal can be animated properly. But now that I'm thinking about it, that might be the exact thing we want to do. We might want to animate something that's not the main cam gimbal. So here you can see that the scale is continually animating, so we can't move it. But if we wanted to move the y-axis, we also can't move it. Why is this axis... it shouldn't be being animated anymore. I don't know why it is sticking to that particular position when the animation is... Let's get rid of this asset store. It's really obnoxious. There we are. I don't remember this being a problem. This doesn't have any of the location or rotation animation calls. So why is it overriding the lower those calls? Well, I mean, I could do a UI overlay and see whether that does anything. Let's go ahead and try it. It's not going to work though. There's a bug where it's not updating the masks properly, which is not my favorite thing. So we'll just go ahead and tell this UI overlay to turn its canvas scale factor. No, we'll just tell it to stop being a graphics raycaster. There we go. So that should be a valid animation. Yeah, it's fine. Now the question is, can we animate the main cam gimbal? We cannot. Can we animate the background camera? We certainly can. Can we animate the ship gimbal? Of course, no problem. So, obviously the main cam gimbal is intended for animations to animate it, so there's nothing like, obviously I want to have the animations animate that. But I didn't think that they would stay stuck. Not a great thing to have happen. So I guess what we're going to have to do is we are going to have to just have it be the opposite on the player-controlled gimbal. So when we enter into... there's no reason to have a null animation since it's worthless. So when we enter into either of these... that you can't see. Either of these menus over on the left, what we're going to want to do is trigger... trigger a cinematics script to target our ship. Because the point is, at this point, we're trying to engage with our ship, right? So we're going to want the camera to kind of zoom in correctly. For that, what we're going to need is an animation, which actually causes the... Oh, I guess we'll just make it another animation. So over here, we're going to just create a new animation, which we'll call SO camera to ship. And it's going to be a very, very basic animation where it just changes the camera position to a side-on view of the ship. So bring it over here, hit record, and then we'll just grab the main cam gimbal, and we'll just take a look at what we want it to see here. You can see how the main cam gimbal at this particular moment is not anywhere near where we want it to be. So we're going to go ahead and bring it to 0, 0, 0. And we're also going to rotate it around to be a little bit more dead onto the side of the ship, like so. And we've got a camera that's floating way above the ship right now. So what we can do is just bring that down with this animation mount until the camera is correctly aligned with the ship. Like that. There we are. And that should be fine in terms of what we can see. If we take a look at the main camera, it's still a little bit low on the screen, so we'll just bring this down. Oh, still a little bit low. That's better. All right, so that should do for now. I think that we can just have it tilt a touch back towards this direction, and we're done. So now what we're going to do is we're going to make that element part of this setup. So we're going to just cut and paste. Oh, I guess we can't paste. There we are. Paste. Nope. Interesting choice on that particular setup. Oh, well, that's good enough. You can't cut. You can only copy and then go over to the other screen and paste and then go back to the first screen and press delete. If you copy and then you delete it, for some reason you uncopy it. It's not brilliant, guys. Oh, well. It's not a loop. So what we're going to want to do is we're going to want to have a dedicated trigger specifically to going into this. So to do that, we're going to need to have a new parameter, which we are going to call cam to ship. Now, with no spaces, please. Cam to ship. The only problem is that cam to ship isn't part of the normal cycle. So we don't want it to hit, when we hit this restart, that's not going to be anything that ever goes to the cam to ship. Because this is not something that ever gets played during scene start. This is something that only gets played live during scene. So we're going to call it a late animation or mid-scene animation rather than a an animation that happens right at the beginning. Because the animations that happen at the beginning have to juggle the cut in. They have to fade in like this. And that means that they have to have some padding and some triggers. Whereas with this, we're not going to worry about it too much. Now, if we hit cam to ship, you can see how that works fine. So what we're going to do is we are going to go back into that animation, that cam to ship animation. And we are going to delete this first key. And the reason for that, I actually think we might have to copy and paste. I don't think we can have a one key animation. But the reason for that is that we don't want it to flicker over to an arbitrary camera position. What we're trying to do is we're trying to get it to crossfade from wherever the camera happens to be. And if it's a little too fast, that's actually not a big deal. We can go back into the animator and we can have this crossfade be extremely long. See? So it's not a big deal. We can go ahead and do whatever we need to do. That'll look a little strange if we got a looping animation, but I don't think we're going to have any cinematic looping animations. So what we're going to do now is we're going to have that trigger when we hit the UI buttons to actually do stuff. So here we've got like all of these options are running around. And what we need to do, here it is, sidebar canvas. These are the buttons in question. What we need to do is turn this off so we can see. There we are. When any of these buttons get hit, we want to make sure that that trigger gets hit. The problem is that this thing is not in the cinematics engine. It's separate from the cinematics engine. So the cinematic setup needs to have a static value that we can call against. We've already got live right here. So what we're going to need to do is have a setup where we can tell the live engine just to trigger a camera zoom and then forget about it. So I guess we can just go ahead and make a function specifically for that. Zoom cam to ship. And all we have to do there is say live.animator. Oh, it's actually static. Never mind. We just say animator dot set trigger cam to ship. Now, once we do that, we might end up replaying that animation over and over, but if it's transitioning to itself, who cares? Because it's a flat animation. The thing that we might be doing, however, is we may add logic in later to not do this repeatedly. It's a little bit dicey to understand how to do that when we don't have a tight control over our animation setup. So for now, we're just going to do it like this. It's a little bit heavy because it's a function that just calls one line, but who cares? It's fine. So now what we need to do is we need to have any time that the buttons get pressed, that function gets called. If we take a look at these buttons, here they are, they have these elements, these onClick elements, but if we were to try and have these onClick elements actually call a static function, they don't know how. And we can't just drag the cinematics onto it, because if this, well, it can. I'm trying to think. It's actually not a terrible idea to drag the cinematics onto it, because although they are separate objects in the scene, both the cinematics and the sidebar canvas are static. So let's go ahead and do just that. We'll drag the cinematics onto it. Here we are. And if we try to set it up, we don't have to do what we just did. We can just set it directly, but I think it's better to go through the cinematic setup and call zoom to ship. But you can see how it barfs, and that's because it's a static function. And that's unfortunate that we're going to have to change it to a non-static function. We'll see. I'll have to juggle this around a little bit. There we are. So we can just repeat that process for both of these guys. And then here. And what we're going to do is we're going to move this sidebar mission down to here. Now what I've done is I've damaged the navigation somehow. What did I do to damage this? Okay, so it looks like I might have accidentally unticked the show graphic. Okay, interesting choice. That's fine. So I just accidentally fat-handed it somehow, which I guess is fine. But that button is a little different than these buttons. Oh, yeah, it doesn't matter. We're going to be replacing all of them eventually. So we don't have the UI over on top of us because I turned it off. But what we do have is the ability to zoom to the ship. There we are. And you can see that now that we're zooming to the ship, we can actually see what we're up to. Now these faces need work. They're very primitive at the moment. I will have to fix them up later on. One of the biggest problems I've got is that I can't drag them or use the mouse wheel on them due to weaknesses in the way that button fields work. Like just having strings of buttons in a scrollable object doesn't work. But it doesn't work because Unity is dumb about it, not because it's impossible. Someone is pogoing up and down the stairs. I hope you can hear that. It's part of the entertainment. All right, so now that we've got that running, we now have the ability to at least see what we're doing when we're trying to fill in missions. That'll make things a lot easier for actually playing the game. If we click it early, it snaps really early. Fun little thing, right? So you can see we want to do command, so here's our command. We can't actually do it fast enough, so we're going to end up having this problem here. We're going to want to compress these things down, do some stuff with that. We'll work on that later, though. Now that we're moving the ship into the middle of the screen, we might be able to do, well, I don't know, we'll figure it out. What I really don't like at the moment is the way these characters look. So they're not like... The idea is okay, but we got a lot of problems with the execution. A lot of the morphs don't really add to the feel of the characters, and their skin feels plastic. It might be that I can do a lot by tweaking the skin textures. Let's pop over to a photo booth here and turn all these photo booths back on for a minute. Turning these photo booths back on. Oh, do I have to? Okay, well, it looks like I can't turn them back on due to the way that it's programmed. I'll just pop over onto the photo booth scene. Here's the scene we've got for setting up photo booths. Hooray! And so what we can see here is that we've got this photo booth setup. Where we've got this generic face that we got from MakeHuman. It's pretty good. It's got a lot of morphs applied to it, and it's also got both bone and blend shape morphs, but it's also got a random skin texture. And my problem right now is that the random skin texture isn't really very good. You can see how we got this problem, no cameras rendering. What we're going to do is bring this camera gimbal out into its own little thing, separate. We're going to call this a debug cam. And with the debug cam, we're going to be able to see whatever we need to see, but we're going to want to angle it so that it has some angle to it. Something just defaultish. We don't have to worry about it too much. And the camera here should have no problems. Oh, let's try it. Monk of Time says, have you looked at a subsurface shader for skin? So there's a couple of reasons why it would be a bad idea to use a subsurface shader for skin. One of the reasons is because it's a tiny portrait, and the subsurface shader stuff is mostly only noticeable for things like glow through on ears and stuff like that. It's the skin texture that's really, really plastic. I don't believe... I have a couple of skin shaders that are... subsurface scattering. I don't believe they improve the effect any, especially when it comes to darker skinned characters. If I was sticking to strictly white folks, which is the standard in sci-fi, then maybe, but it's not a great look for anybody whose skin is darker than that. So right now we've got a problem, and that is that the photo booth keeps deleting itself. We're going to put in a don't turn off option. So when we're doing the debug mode, what we're going to do is we're not even going to set up this portrait unless we're not in debug mode. If not debug mode, then set up the portrait. And then down in init, I believe that we turn ourselves off. There it is. So on render object, if camera equals cam, then set active false. So do that only if we're not in debug. There we are. And that should let us actually see what's going on here. So I can show you some of the other skins that we've got in terms of cameras, but let's just go ahead and set this up, hit play, see what we got. I don't think we need this camera anymore. Darn it. Undo. Delete this. Alright, so it looks like it didn't even fire. Let's go ahead and hit init. Here you can see what it does is it moves the character around, and you can see we've got this really chalky skin tone. The problem with the skin tone is, of course, that the basic setup is very primitive. It's a texture that I made, but the texture is very soft, it's uninteresting, and it doesn't have any of the actual density that skin has in terms of tone variation. But we can see what it would look like with different sorts of materials. So if we pop on down into the materials section, oh, it must be in the meshes materials. Here we are. So we've got a whole bunch of these skin textures, and it includes a couple of AO-based skin textures, although I don't know if they're in this project. So here's the custom skin texture that we created for skin testing. I'm going to duplicate this and see if we can change the shader over to an SS shader. I don't know why I said AO. It's just SS. Come on. Come on. Da, da, da. I don't think we loaded it in. I mean, I could load it back in. We might as well. So we'll pop open that store shop window. Where's the shop window? Asset store. So if we take a look at subsurface, I've got two of these. This one looks like it's not going to work anymore, so we'll just try this one and see if it works. And we'll just review, now that we've had a couple of minutes to, a couple of months to look at how the skin looks versus everything else, and I've gotten a chance to bake it in my brain a little bit. We'll see whether or not the SS shader has any value. Even if the SS shader does have value, we won't be able to use it. We'll have to duplicate it using trickery because it doesn't have any of the features we need in terms of overlaying scars and stuff like that. But I honestly think that what we really need to do is just kick up the skin textures. I think I just have to repaint those skin textures a little bit less shit. Oh, it looks like I'm not sure whether I'm live or not. I'm gonna hit reload on Twitch and see whether or not I'm live. Yeah. For some reason, Twitch will sometimes crap out on my own personal view, but I don't think it's affecting anybody else. Do we get it? Got it? Good. So here's skin test 1. We'll call it skin test S subsurface. And we'll change this custom skin shader over to the subsurface. Now I don't think... so let's go ahead and duplicate this photo booth and then just set this photo booth back up as the default and turn it off. So I don't think that that's going to work just as is. Yeah, you can see how it came up as total barf. Because it expects us to have these values built in, and unfortunately those values are something specific. So I think we're going to have to go down into this and find the demo skin here. So you can see that this sample shader is actually not the same thing. Interesting. It doesn't look like there is any... They're all cropping up as a strange setup without any sort of value to them. If we take a look at these meshes, the lighting texture that we're using, or the texture in general, this is not a good one. It's not the correct one. I guess we'll just take the sample, deferred sample. But you can see how it's not ready for prime time. This is not really a problem because I can always change it, but it's interesting. I thought that this was the one that had the ready for prime time defaults. Clearly that's not the case. We can pick up all of these speculars and stuff because we already have all this crap I built up for my shaders. It's just down here somewhere. So if we take a look, we got a gloss map, which is the same as a specular map as I understand it. We've got a profile. I don't think that that's something I'm supposed to be filling in. I think that that's something that that is supposed to be like a ramp. And the last time I checked this, I was pretty sure that it came with one. So I'm not sure why it doesn't come with one anymore. Oh, but hold on. If we hit play, as long as we don't update it, but it's really, really dark. I think that I've screwed it up, but I can always try and make it brighter. The reason it's dark is because, oh, I clicked on something. Sorry about that. The reason it's dark is because I never, Mifa says I'm alive. That's good. The reason it's dark is because I never had any of the background light turned on. These SSS skin shaders, they require you to have a lighting hierarchy. Here it is. So they're assuming that you're going to have... Oh, I do have a lighting. My lighting box is turned on. So why is it this dark? I don't think it's supposed to be. I can always add in more lighting, but it doesn't seem like that's the right choice. Oh, there's something screwy going on here, and I don't know what it is. This is not a very good example of how subsurface shader works. It looks like I have borked it somehow. I think that the defaults are not giving me anything decent here. What I can always do is switch this over into one of the others. Can we get a skin here? Skin test subsurface skin. Nope. Yeah, these are all nonsense. I have a feeling that this might not be the subsurface shader I was using, because this doesn't seem right. It seems wrong. I just delete that. But if we put the skin back here, so this is the skin, the default skin that we get using just default skin test setup. I think that it's the same. There we are. I think that that's the same skin we actually use in the default head here. Yeah, skin test. And you can see how it doesn't look too bad in terms of having the right properties to be skin. It's just that the skin itself feels a little bit chalky. If we pop on over into this lighting gimbal and delete it, it turns into a very dark shade, because what we've actually got here is a fairly dark skin color. I think it's, yeah, between medium and black. But we can always go brighter by choosing lighter skin tones, and that's what it does automatically when we are doing this stuff on the fly. We pick randomly from some skin tones that we've got lined up. And so it doesn't always end up being, super dark or super bright. But because the way that the skin works ends up being the difference in how the skin needs to look between dark skin and light skin is a problem, and it's one of the ones that's really, really difficult to fix up. So here you can see that we've got a darker skin tone, and it's a very soft tone, whereas the light skin tone is extremely harsh. But a couple of the other things we've got going on is, even without the skin tone in question, the characters look goofy. So it might be that, focusing too much on skin tone might not be the thing that matters. It might be that we want to have less goofy characters. And bringing in less goofy characters is a twofold effort. The first is that the camera gimbal needs to have its extents adjusted. It's too much gimbaling down on the x-axis. We're going to go ahead and fix that now. Here it is. It says between negative 20 and 20. We're just going to make that between negative 10 and 10 on the x-axis there. And that should bring some of the goofier camera angles down to scale here. So we're no longer going to get any of the super low angle cameras or super high angle cameras. We're just going to get a bit of variation. And you can see here we've got a glitch where there's no Z-plane clipping. There's no depth. I forget what the name of it is. But because there's no depth, there's no way for us to render, to guarantee that one thing gets rendered behind the other. So what we're getting here is that the two transparent materials are being rendered in a random order, and the random order is in fact bullshit. The way around that is to change the values of either the materials or the camera, our choice. Let's try changing the materials first. So if we make the eyes render first, maybe that'll help. We're going to come down here and take a look at the eye timing. It's not an option. That's interesting. I thought that the standard shader had the option to change the exact timing that it would run. That's not great. So if we change this to something else. Now here's the thing. I'm using a default eye material. I didn't build this one, but we're going to have to because this one's a brown eyes, and we're going to want to come up with all sorts of fun colors for eyes. If we make it opaque, you can see the problem. The problem is that there is a glossy layer over the top of the eye that is built to make the eye seem realistic. And because of that, it ends up looking weird. If we do cutout instead, we'd get an eye that's not too bad, but the gloss is wrong. So you can see that that's a little bit strange in terms of how the gloss looks. But the good news is that it shouldn't malfunction with the setup of the helmets. So if I were to find a helmet here, I also got some shadow problems with this hat. We tried to work that out last time and it didn't work. Come on, give me the helmet. There's only like 3 things that you can put on your head. Oh, look at that. We got some clipping problems. There we are. You can see that the helmet now works. It might be a little bit too opaque, actually, but I can bring that down. So if we just were to grab that helmet object, it's got a glass transparent shader attached to it. We can just bring that albedo down to like that, and that'll be helpful. And even though we're in play mode, that'll still save because it's not a play mode thing. So that should be fun. We're currently doing some emission on the glass, but it doesn't appear to make any difference. So whatever. But if we continue to look at these faces, the problem we have is that they are goofy. The actual morphs that we're applying are extremely cartoonish. So we've got a couple of options as to how we want to deal with that. Also, we're going to have to change the lighting or something when we're dealing with darker skin tones. The darker skin tones don't end up looking quite legible against these backdrops. I could always have the backdrops be the opposite color as the skin tone, so you'd have light-skinned people against dark backdrops and vice versa. So here you can see, for example, we've got really big eyes, and there's nothing fundamentally wrong with that, but it makes it look pretty cartoonish. And here you can see we've got both big eyes and this long rounded face. If you look at these characters for too long, you get used to them. But I don't think that that's really what I want to do. I think what I need to do is make it so that these characters feel like they exist. Oh, there's some problems. I didn't bother to do any extensive work on that, so they're not always going to work out. We'll figure it out later. But there's a lot of issues where these faces don't get quite the performance they need. And the reason for that is because there's a glitch in my morph code. And it's time for us to try and track that down, I think. If we were going to take a look at this skinned mesh render, this has all the morphs applied to it. So if we zero out all of these morphs, we need to unpause, my bad. There. You can see that what's left is just the core bone modifications. But the problem is these core bone modifications ended up making this character do this, which is not what we wanted at all. You can see how this scoop here doesn't actually pull the eye forward enough, and that ends up causing this problem here. And I think the problem is that our morphs are playing backwards. So if we were going to take a look at the morphs that we actually got out of this, bone morph, shape balloon, eyes almond, eyes small, face short. So face short at 0.75 is the thing that's doing this, right? So if we were to undo that, what we can do is we can go over to the head morph element, which is, I believe, on the head itself. Here it is. We can have this be called face short. Oh, I already knew it was going to be a problem, so there it is. And what we can do is we can apply it. And you can see that what we get is something that's not nearly that bad. So the problem is that what we're getting in the end is not this. Because I think that what's going on is that the eyes, when they grow, are also causing us a problem. Yeah. So there's like combinations of shapes that end up causing issues, and that's something that, let's just reset this here. And that's something that we're going to have to deal with. But a big part of the issue is that when I initialize these, they're not the way you might think. So for example, if I were to create a new morph called test, and I were to grab the face bone here, bottom of head face bone, I can do this, okay? So there, I've just moved one of these bones, and then I can scan as morph. But if I then apply the test morph, it goes the opposite direction. Now the weird thing is that this isn't at all universal. So if I were to clear that, and I were to instead make it so that it was moving the jaw. So let's grab the jaw here. Bottom of head, lower face, jaw morph. If I were to bring the jaw open like this and tell that to scan as morph, and then I were to apply it, you can see how that one works. So for some reason, one bone is backwards, or one bone so far, which makes it a little bit challenging to do this, because if I'm trying to change the shape of the face, and the shape of the face is occasionally backwards, that's nonsense. How am I supposed to deal with that? So the core problem is that the bones that we're modifying for this are, I believe, the bottom of head bone, this bone here. This is a really, really important but delicate morph. It really changes the exact position of a lot of verts. And you can see that if you get this pug nose things, this is a bad thing to have, but it's actually not that hard to fix. All you have to do is move things a little bit, right? So the problem is that if I'm doing rotations backwards when I'm setting it up, I can't see what I'm actually doing. It's just nonsense. So in order for us to have that work, we want to have that go in the right direction. So the question is, what's the difference between the bottom of the head bone and everything else? And the answer is that it's got 180 degrees of rotation around this axis. And I think what's happening is that when I'm applying this morph, it's somehow getting it backwards due to that negative 180. If we take a look at the rest of these bones, none of the other ones are rotated 180 degrees except for the eye mask. So we can test this by rotating the eye mask and see whether it also rotates in the wrong direction. So we're going to rotate the eye mask way up like that. And then we're going to mark that as a shape. And then we're going to apply it. And you can see that that's backwards. So when the bones have a 180 degree rotation, for some reason it ends up inverting what I'm doing. So let's take a look at the code for that and see whether or not we can figure out why those might be backwards. So we've got a bunch of bone-related stuff going on in here. I think that we want to go down into the crew editor. Bone Wrangler, raw morph classes. I believe it's in here. Morph bone. So here's the actual thing that does the work. When we tell it to apply, what it does is it moves the scale and the position, and then it multiplies the rotation, the local rotation, by okay, so this local rotation is the animation. So it lerps between the quaternion identity and the animation's idea of where it should be, and by the percentage that we want. So that means that you can rotate it slightly. And this line here actually ends up inverting it if the transform's local rotation is rotated 180 degrees around the x-axis. But it was rotated 180 degrees around the x-axis when we stored the value. So it could be that when we're getting the delta, what we're actually doing is getting it wrong here. So when we're finding out what we would like to see, when we move the bone and we say save this bone change, this is what gets called. We get ourselves the original bone, and we subtract the position of the original bone, the scale of the original bone, and then for the local rotation, we multiply by the inverse of the original bone's local rotation. And this must be what's causing our problems. Quaternions are always going to be annoying. Anybody that says otherwise is either lying or a genius. But in particular, the idea of subtracting and adding quaternions doesn't work. You need to multiply and divide quaternions, and you do that by inverting them, because you can't actually divide quaternions. So if you want to divide a quaternion, you have to invert the quaternion, which is what we've done here. We've taken the original location and we've inverted it. But it turns out that that's not valid when the original local rotation has 180 degrees of rotation around the x-axis. And I'm not sure why that would be. So fundamentally, one of the things we have here is we are assuming that this local rotation and that this local rotation are going to be the same, and what we're going to be left with is a result that we can add back in. So the idea here is that we are removing the local rotation, and then we are multiplying it back in. Maybe I'm misunderstanding how to do that. Quaternion subtract rotation. Obviously you can't do this, but it's what we're doing, so. It could be that the inversion of the matrix doesn't actually work in this case. It might be that the inversion is not properly inverting right here. This might not end up creating what I think it's creating. And it might not be subtracting out what I think it's subtracting out, because the inversion is not guaranteed to give you the exact inversion. It's going to give you something that's mathematically equivalent. But there's no other options. The only other option I can see is we could have the local rotation equal to the local rotations invert time. Well, let's try it. Let's go ahead and comment this out and put in some interesting variations. What happened? What the fuck happened? There we are. And we'll put in some interesting variations. Local rotation equals value to subtract dot local rotation times quaternion dot inverse. This can't work. This doesn't make any sense. Does that work? No, it won't work at all. There are a couple of things it could be. I'm going to go ahead and just try this real fast. It's not going to work. And then we're going to go ahead and see what else I can try. So we're going to let this recompile. Didn't it? So now what we'll do is we'll go over to the head and just take a quick little look. We got our test set up still. Go down to there it is. That took a long time. Bottom of the head, let's swoop it down, and then we'll tell it to save that test. Scan as morph, and then apply. Named shape. Oh, it worked. So now what we're going to do is we're going to see whether or not it works for all cases. So let's find a bone that doesn't have that problem. For example, the jaw morph, which we did before. And let's see whether or not now this is backwards. Yeah. So basically, these two options both work for different bone types, different bone rotations, which is fascinating to me. I'm not sure, but I can always just change which ones we're using based on whether or not the bone needs to be inverted, I suppose. If we take a look at the bottom of head bone here, the X is at negative 180, and that's going to be true of a lot of these. But some of these bones have values that are not near 180. They're rotated by a certain amounts, but they're not rotated by around 180. None of these bones are ever going to rotate by more than 90 degrees because that doesn't make any frigging sense, right? So one of the questions we've got is it a situation where it's a large negative value, or is it any deviance away from X? So let's go back over here and set this up again. Let it recompile. And then what we'll do is we'll move this bone forward, go to the head, scan as morph, apply. Okay. So the X rotation appears to rotate the object around the wrong axis. So when the X rotation is 180 degrees, then what we're getting is we're rotating against vector 3.left instead of vector 3.right. And when the x-axis is off by 90 degrees, what we get is a rotating around x, vector 3.up instead of vector 3.right. So that means that the x-axis is fucking us up pretty good. Just to test this, I can go ahead and move this thing again. Like, say, this time I'll rotate it to the right. And then we'll go ahead and save that, scan as morph, and then... Oh, interesting. Oh, that's the head bone, my bad. I meant to change the bone. Rotate to the right, scan as morph, and then apply named shape. And you can see how it's 90 degrees off. And the reason it's 90 degrees off is pretty simple. It's because the bone has been rotated by 90 degrees around the x-axis. See? So there's something screwy here. Let's see if this fixes it or it breaks in the other direction on the same axis, in the same way. So to do that, we're just going to have this move again, but we're going to have it move in another direction. So we'll just swoop. Oh, no, wait, sorry, I wanted to do it this way. Swoop. So once again, last time it turned towards the camera. This time it should turn away from the camera, or it'll do something else. Yeah, it turned away from the camera. So these two are 180 degrees off from each other. That's the difference here. That means that neither of them is the correct solution to this puzzle. All I'm trying to do is remove the local rotation so I can store the amount that I changed it by as its own value. Because that way I'll be able to add multiples of those together by multiplying, I can multiply 8 different factors together to move the bone offset more and more and more. But I can't do that if I can't get rid of the original values, if I can't remove the original values. One of the things that it might be is that the local rotation might not be the local rotation. It could be that the local rotation is not currently set up properly. So if we take a look, what we do is when we have this morph bone, so the thing here is that this is not attached to anything. This is a free-floating class. It's not even a Unity event. It's not even a Unity class. It's just a raw C# class. It stores a transform, and this is the bone in question. When we tell it to morph, it saves the bone and all of these values as the local rotation, local scale, local position. So that should be correct. It should be that the local rotation is in fact correct, but for some reason, what am I mistaking here? Wow, this is something I should have done off screen, because now I thought it was going to be an easy fix, and I am just not getting it. So quaternion rotate by remove original. No, people are. This is not a good combination of search words. Remove and add back in later. Correcting the yaw part of one quaternion by another. Okay, that's not it either. What am I getting wrong here? So there's only two parts. There is the transform that we currently have, the quaternion that we currently have. And then there's also the quaternion that the bone originally had. And those are the only two moving parts. So we only have a couple of options. In order to get rid of one of them, we're going to have to multiply by the inverse. But the problem is that multiplying by the inverse doesn't actually get the correct result. So if we take a look here, we can go back over in here and we can just take a quick little look at the test bone morph. Let's reset this. Clear. Down here in test, we've got one bone, and what we've got is a local rotation. And the local rotation is an x-axis rotation with the W of 0.9, and these values are both basically 0. Now, if we take a look at the actual bone here, there we are. What we've got is x and y are both 0.5, and the W is 0.5. These are a whole bunch of 0.5s. And if we take a look at the lower face area, what we've got is a W of 0. So it looks like it's the W that is causing us these problems, but I don't know why. I mean, obviously we could change the W, but it would cause undue harm. I don't remember this ever being a problem before. Unity quaternion W is fucked up. Maybe there's a built-in quaternion function that I'm just ignoring. Quaternion dot. So if we take a look, we've got from to rotation, but that rotates from to vectors rather than quaternions. So you can see those are just vectors. We can lerp between two of them. That's not going to get us anything, though. We can rotate towards. So we can actually get a quaternion that rotates from where we were to where we are. Let's go ahead and try it. Let's try that. Local rotation equals quaternion dot rotate towards, and we'll go ahead and have the from be the value to subtract dot local rotation, and the to be the local rotation, and we'll give it 90 degrees max angle. Oh, people are giving me some advice here. So Monk of Time says, why do the bones have that rotation? That's because Blender was playing fun tricks on me. Ha! Very funny, Blender. Mifaz says, transform.rotation times quaternion.Euler. I'm not familiar with how the Euler elements are going to end up causing us issues here. Let's try this, since this seems like it should work. And if it does work, we'll be happy. And if it doesn't work, we'll be sad. A slow recompile. Back to normal mode. So once again, we're going to drag this bottom of the head down, and then we're going to ask it to save that as test. And then we're going to apply it. Perfect. As you can see, nothing went wrong. So, that ended up rotating it 180 degrees, and when I applied it again, it rotated it right back to where it started. What? Let's try rotating a different bone. So let's reset and grab the top of the head, which doesn't have that problem. And then we will just save that change and apply it. That seems to actually still work. So let's go ahead and try that one more time. Okay, no, it's not working. It's always going to rotate that direction regardless. That's interesting. So let's clear it. Try one more time. Maybe I screwed that up. Scan as morph. Apply named shape. Okay. So it doesn't look like this actually does what it should be doing. So Mifaz says it's transform.rotation equals new rotation times quaternion.inverse other rotation to subtract. That would be this right here. That's the one I have been using. That doesn't work if the rotation around the x-axis is anything other than 0, because it rotates around the wrong axis when I add it back in. The inverse does not correctly calculate the inverse. It inverts it around the wrong axis. And I don't know how to fix it. I was hoping that this rotate towards would work, but it doesn't appear to actually do what it says it's going to do, because what it should do is move from this to the current rotation, and it doesn't. So what we're going to try to do here is substitute in the basis, not basis, it's called something else, transform. Because one of the things I want to remove from this complication is whether or not there is a problem with this cached value. So we're going to try it one more time, this time with the local rotations being properly cached. So if we then move the top of the head down, and then save that, and then apply it, it goes the wrong direction. How is that possible? Because now if we move the bone up and we scan that as a morph and we apply it, it still goes up. What a strange thing. So now that Mifaz is paying attention, I'll walk back through this. So the thing I was originally using was exactly what you are telling me to use, which is local rotation equals local rotation times the inverse of the old local rotation. And that should leave behind the remainder, which would be how much local rotation there was from where the original is. So if we do that, and we let it recompile, what we can get out of that is something that works for some bones. So if I were to do this, and then I were to scan it as a morph, and then I were to apply it, works great. So that's how we want it to be. But if I grab, take a look at this rotation here. Now if I grab the bottom of the head, this rotation. If I grab the bottom of the head, so here's the top of the head, 0, and here's the bottom of the head, 180. If I try and extend the face, and I go over here, and I tell it to scan it as a morph, and then I tell it to apply it, it goes backwards. Because the x-axis is wrong. And we've already tested this with a couple of other bones. For example, there's a bone here that has a 90-degree rotation. So if I were to rotate this bone around, let's say I'll move it forward. Now when I scan this morph, and then I apply it, it rotates 90 degrees off from the correct axis. The x-axis rotation, as displayed here, is causing us to rotate around the wrong axis. If the x-axis rotation is 180, then we end up rotating around from 180 degrees. But if the x-axis is 90 degrees, we're just off by an orthogonal amount. So the problem here is that we have an axis that's not lining up properly. And quaternion.inverse is not doing the trick. One of the things it might be, let's try it. I don't believe it's sensitive to order of operations. That wouldn't make any sense. But I might as well try it before getting even angrier. So now that we've made it so that the rotation amount comes first, it shouldn't be any different. It should be exactly the same. What? Wait. Does order of operations matter? Maybe that's a big part of the reason I've had a hard time wrapping my minds around quaternions, because I thought that order of operations didn't matter. Oh, fuck me. Okay, it's all solved, everybody. Thanks for your help. It turns out that I am just kind of an idiot. So the problem now is that we're going to have a lot of morphs that are just plain messed up. We're not going to want to use this guy. Let's go ahead and get rid of them, because this is the debug version with a whole bunch of random crap attached to it. This is the version that's actually going to echo. We're going to remove the test from this version. We don't need it. But we have a problem. A lot of these are now going to be wrong because they are no longer set up correctly. So if we go and we say, okay, well, let's take a look at the face short. You can see how that's not the face short. And the reason for that is simple. It's because I made the face short backwards because I couldn't get it to work. So we're going to have to redo some of these. And let's go ahead and do some of that. I locked the wrong thing. There we are. So here we are on the main photo booth. Turn this main photo booth back on. Turn this photo booth back off. Go over here to the head and grab that face short. And we're going to make sure that this works. So if we apply it, it's wrong. Fine. That's fine. I'm not upset. I'm not upset. Not that we can get it right now. So now what we're going to do is lock this in place. Go down to the face short bone, which is this guy, and bring it up to pug level, like so. But we can adjust this so that it doesn't collide too badly with the eyes and the eye mask and that sort of stuff. So the way we're going to do that is we're going to bring this up, and then we're going to bring it forward. Maybe not. Let's go ahead and adjust the eye mask at the same time. So if we grab this eye mask, one of the issues is that we end up with this part becoming this nasty divot when the eyes get adjusted in terms of their size. So if we bring this eye mask to a different angle and then down, we can soften the elements underneath the eye that get damaged when that eye mask happens. We can also drag it back slightly. There we are. That might help. Let's try it. So we're going to scan that as a shape. Now we need to do face long, or face long. So with face long, we need to do the opposite. So we're going to just drag the bottom of the head down like this. You can see we've got an errant vertex up here that's connected to the wrong bone. We can fix that later. It doesn't affect us yet. We're just going to go ahead and scan that nice and simple as is. Now, face wide is a question. Is face wide actually something that is going to need to happen? So let's go ahead and apply the named shape. Okay, so face wide works because that's a scale rather than a rotation, so that's fine. Let's go ahead and start to polish some of this. Cop Disbong says, you found the fix so quick, lol. I've been watching you on the problem for a bit. Leave to pee, come back and say you're saying it's fixed. Yeah, I just had an order of operations problem. And I feel really dumb about it. It's fine. It's fine. Everybody makes dumb mistakes. So what we're going to do now is turn this debug element back on. And we're just going to see what sort of polishing we can do to get this face to never look overly dumb. So we're just going to hit randomize. And you can see it looks really dumb. So we need to fix what is making this face look dumb. And in this case, what we've got is a face that has this shelf. You see this hilarious shelf. And the reason we've got this shelf is because we've got a face projected at 1. Which is apparently a little too much. So let's go back to the face projected element and see whether that truly is the problem. So if we apply the named shape, you can see how that really is pretty cartoonish. So what we're going to do is we're going to pull that back a little bit. Is it the bottom of the head or the lower part of the face? I'm just going to pull that back a touch. Yeah, that should do. And we'll go ahead and scan that in as the new face projected. And we'll just repeat the process. Oh, I did only the bones there. We want to do everything all at once. My bad. There we are. So here what we've got is a slightly cartoony face, but the question is whether or not this face is too cartoony. From the side, I think you'll agree that it's probably a little bit too cartoony. The overall face isn't actually too terrible, except for this lip here, which is the sort of lip you'd get if you had a different facial structure around the lip. And this is the sort of thing we're always going to have a problem with when we are doing this kind of setup, because these are all free-floating pieces. They're not really contextually linked. If we take a look at what's actually causing that, that's actually a shape key issue rather than a bone issue. There's no bone for the lip. So if we were to take a look here, we've got this lip big at -10, which isn't the issue. It's this lip bottom. So if we reduce the lip bottom down to 0, oh, I guess it is a bone problem. So it looks like we have a problem where the jaw is projecting a little bit much. Let's take a look. Jaw underbite. So the jaw underbite is a little bit aggressive. We're going to go ahead and polish that back a little bit. Bring that back into something more useful. Jaw underbite. Because the jaw underbite is fine if you have a huge jaw, because then, proportionally, that much underbite's not an issue. Unfortunately, nobody has that kind of a huge jaw. So here's what it looks like. Let's go ahead and pull it back into position using the jaw morph rather than the jaw itself. Yeah, that's fine. Scan as morph. So let's go ahead and keep trying this out, see whether we can get it to stop looking impressively goofy. So here what we've got is a face that it looks a little bit cartoonish, but it's something you can live with. The texture is extremely flat. We're going to punch up the textures, the facial textures. I have to have ZBrush open to do that, so I'll do it some other time. I don't want to have to fuss with ZBrush right now. That's actually not too bad. If we had hair and stuff like that, it wouldn't be terribly noticeable as to how crappy it is. But the eyes are really aggressive. They're looking in the wrong direction, and that's just because the eye tracker is set to look straight at the camera, but the eye is not exactly where you might think it is. So it ends up looking a little bit too aggressive. One of the things I could do is for the eye tracker, I could have the position of the camera, or the effect the position of the camera has. Let's go ahead and try that right now. So over here in head, we have an eye tracker. And what we do is we just say look at target. So what we're actually going to want to have here is lerping between that and the original. So quaternion orig equals left eye dot local rotation. And then we're going to go ahead and say left eye dot local rotation equals quaternion dot lerp orig left eye dot local rotation 0.5. I'll make it 0.7. And do the same thing down here for the right eye. All right, that might soften that camera freak out, the sly look. We can also have eyes that look in directions that instead of being looking at the camera, they're making expressions or something. Figure that out later. Right now we have no expressions built into this engine at all, which is one of the reasons these feel so dead. Maybe I should focus on that rather than on fixing skin tones. Because I think that if we had some emotion, these might come to life a little bit better. So the problem is that none of the blend shapes are concrete. I haven't figured out exactly what I want them to be yet, so I might work on that. Yeah, this face is fine. I don't see it as too cartoony, but again, it's hard to read. It doesn't stand out against this dark backdrop. So I think what I want to do is this dark backdrop back here, which is just whole dark. It's got this rather dark albedo color. So what we can do is we can just have this photo booth keep track of the backdrop and change the color of the backdrop to be the opposite of the color of the face. So if we were to do that, we would want to take a look at the skin editor. Here it is, Skin Wrangler. The Skin Wrangler should probably be what keeps track of the mesh renders it's trying to contrast with. Backdrop elements tooltip for lighting fixes. So what we'll have down here is here it is, init. So we have this situation where each of these skin types has a tone attached to them, and it'll be trivial for us to apply that tone to the background elements. So we'll go ahead and do exactly that. If there are backdrop elements, we're going to want to get a color that is between the skin tones, the skin types. It's based on the skin types. If we take a look at the actual skin type definition, we don't have the option of having a color. Oh, here it is up at the top. We don't have an option of adding in a color. We could, but it would just be more stuff to keep track of. But we do keep track of a tone, where higher is brighter. So what we can do is we can have this tone map to a what do you call it? Not an eye tracker. Animation curve. There we are. And that's going to be, by default, an animation curve dot linear. I don't know whether I can do this, but we'll try it. I think that might barf. Let's go ahead and just take a quick little look and see whether that barfs. No, it's fine. All right, good, good. So the Skin Wrangler now has this backdrop tone adjust, which we're actually going to just adjust so that it's like this. There we are. That'll do. And what we'll do is we will make it have that as a backdrop. So we're going to take the tone, float tone equals a dot tone plus b dot tone. And then we're just going to divide tone by 2. So that should do it, I think. We'll find out. And then what we can do is we can grab that value out of our renderer here. I believe that it goes, the skin tones go from 0 to 5. No, it's only 0 to 3. All right. So we're just going to go ahead and divide it by 3. All right, so now that we've got that, all we really need to do is get the result, which is tone equals animation curve dot. Oh, sorry, it's actually the specific backdrop tone adjust. Eval, evaluate, tone. And then we're going to create a color, backdrop color equals new color, tone, 1. Material property block. Oh, is that not happy? I think it's fine. Let's find out. We're going to call this backdrop material property block. And we're just going to set the BD material property block dot set color albedo, and then the color value will be the backdrop color. And then what we'll do is we'll go through all of the elements for each mesh render MR in mesh renderers backdrop elements. MR.set material property block. Oh, it's not called a material property block, it's just called a property block. Yeah. Set property block BDMBP. That should work once we set the backdrop elements correctly. The only question is whether or not underscore albedo is the correct term, which we can find out very quickly. We'll just grab a hold of these backdrop elements and take a look at the standard shader, which we can do by clicking here and saying select shader. And there you can see it's actually color rather than albedo. So we'll just fix that up. One of the other issues we might have is that the backdrop might just not be getting enough light. We'll find out soon. But before we can check whether or not the backdrop's getting enough light, we need to adjust the backdrop elements to include the backdrops. So if we take a look, here they are. Just drop that in and then drop this in and then hit play. So now when we initialize this, you can see that when the character is very pale, the backdrop becomes pitch black. And as the character gets darker, the backdrop gets brighter. Aha, see? So that should help us with some readability. It's obviously, the backdrop is obvious, you just placeholder gibberish at this point. But the point here is that we can adjust readability by changing how the backdrop looks. And I don't think I want it to go down to black. Black is a little bit too low. So let's just bring this to a little bit of a more even keel. Something that's more along the lines of this and this. And obviously I don't need it to go all the way down, so that's fine. And what I'll probably do, I don't know if it's going to be on screen or off screen, but clearly I need to add in emotions and I need to work on the blend shapes. The blend shapes are not currently adding very much to these characters, but in reality, they're going to have to do a lot of the heavy lifting. The bone adjustment is important, but that just changes the core shape of the underlying face. It doesn't give you nose shape or eye shape or anything like that. Well, we got some pretty extreme bone morphs here to the extent where we've created some folded over verts. It's pushing it, but it's still better than it was when we started. Got some real shadow problems. We're having shadow problems with a lot of these helmets and hats. There's an issue where, for some reason, Unity is refusing to use tight shadows. I'm not sure why. Even if I tell it to, it makes no difference. Maybe I'll look into that a little bit, but until that happens, we may have to do something else like screen space. Well, let's try that. Let's go ahead and try it right now. So we're going to save this and save this. And then what we're going to do, turn off debug mode. Then what we're going to do is take the camera and apply some post effects. So we're going to want a post-process layer here. And then what we'll be doing is switching this layer over into diorama or photo booth. And then we're going to have to add in a photo booth volume for post effects. So I guess we'll put that here. It doesn't really matter. The problem is this is not a very good way to do it, and I've complained about this lots, and people have been like, oh, it works fine. It really doesn't. But basically what we can do is we can create this post-process volume, right? But in order for this volume to have an effect, we either have to make it global or we have to give it a collision. I guess we can give it a collision. So we can say that now it's going to be against this box glider, right? Fine. We'll give it a shot, see how it looks. But we need to create a new profile, which we're going to go ahead and we'll call it, fine, head profile is fine. And we'll add some effects here. What we really want is ambient occlusion. That's like the number one thing we want out of this. So we're just going to pop on over into the game and see what happens when we add in some ambient occlusion. It doesn't seem to do anything, and the reason for that is simple. It's broken. Why is it not working? I'm pretty sure I don't have to be in play mode. I'm pretty sure it just works. Oh, okay. So as I was saying, the real issue here is that the box glider is not necessarily the best way to do this because it only... I'm not sure what the logic is as to how this camera is supposed to actually interact with the box glider. Is it if it's inside the box collider the effect gets run? Yeah, okay, that's fine then. I can live with that. So what we can do, I don't want it to be global, and the reason it shouldn't be global is simple. There might be several photo booths, and I don't want them to overlap. I could create one global photo booth layer, but I'm probably going to want to tweak based on skin type, so we might come back to that later. For now, it's fine. All we really need to do is adjust this a little bit like that, maybe. And then what we can have is a setup where when we are firing off hats and stuff, we can get the screen space AO to affect the areas underneath the hat. It's not going to be as good as having actual shadows, but the shadows are barfy. So what we're going to do is we're going to go over and turn the shadows off on our meshes that we're adding in accessories. So we're going to turn cast shadows off for all of these because their shadows are malfunctioning. No, it's not working. If we pop on back over to the camera, it's actually here. This is what's doing the work, I believe. Yeah, here it is. You can see how it's not running. This isn't doing jack shit. If we make it global, now it's working. So is the problem that it was... Oh, the problem is that the box glider just changed back to the default size. Obviously, that's way too aggressive. We're going to go ahead and try it out. See if we can get it to feel a little bit better. So here we are down here. We pull this back down to like point there-ish. Then we can try a couple of randomized. We're definitely getting a little bit of... it's not really believable. Yeah. In order to get enough ambient occlusion to make the helmets feel real, we would have to seriously screw up the rest of the face. And we've also got the problem that it's not actually working. There's some errors in how it's being presented, which is a shame. I don't think that the ambient occlusion is... I guess it's adding a little bit. Not much, though. Let's see if there's any other effects that seem like they might be useful to us. We got auto explosion, bloom. These are all pretty iffy. We could do depth of field. Depth of field would be a fun one for us, simply because it would allow us to blur that backdrop, which is a pretty annoying thing to have in our camera. So if we take a look at this, the focus distance can be altered, and we can bring it however we want it to look. So there we are. We'll bring it to here. And then what we'll do is we'll make this max blur size quite large. Since we're not streaming this, it's just one little quick shot. It'll probably be okay. So we're gonna just hit this up with a randomize. And what we're trying to do is just get it to feel like the person is having their picture taken. And I'd like just a little bit of fuzz on the back of the ear, and then the backdrop to be out of focus. That's not too bad. See that blur? That blur is a bug in the code. I think that I need to enable the Z stencil, and I can't remember how to do that. Oh well. It's not something anybody's going to notice at the sizes we're talking about, so whatever. I think that we might be using... let's go ahead and go back down to that effect. And what we'll do is we will turn the debug here to just game here. If we turn it on and off, you can see how we're blurring a little bit too much on like the cheekbone. So this focal distance is a little bit too... Yeah, just bring it up to 2.5. Like that. That should be fine. Yeah, more or less. The effect is pretty small. Oh, look, here's a cartoony face. Let's see what this guy has to say here. He's got tiny head, brow high, face long. So the problem is that he's got the face long and the brow high, which gave him this really aggressive... Oh, and then the heroic jaw. So he got all of the face elongating bone morphs at the same time. To be honest, I'm not too concerned about that. If it's because we got a lot of bone morphs that all do the same thing stacked up, I might remove some of those bone morphs because they're kind of overlapping. But in essence, it's fine. If you occasionally run across someone that looks doofy, great. I just don't want everybody to look doofy. I want the defaults to look okay. I want the ability to have these... so this, for example, is a great face. It's utterly a believable face. You're like, yeah, okay, I can see that person on my crew. But I don't want to have faces that are They have an upturned nose, and they've got their mark, their arbitrary freckle that I put on as an overlay just for kicks, right on the tip of their upturned nose. What an unfortunate person. Yeah, most of these are pretty okay. There's a lot of work that still needs to be done with the blend shapes. They're pretty basic, but these characters are just cartoony enough that I'm not too concerned about it. Obviously, some work needs to be done in making these helmets and stuff actually bind correctly to the bones or the shape keys, so that this sort of thing doesn't happen. I'll have to think about how to do that. We're gonna have the same problem with the hair. But it's been 2 hours, so I'm going to stop. If you have any questions, now would be a good time to ask me. If you don't have any questions, now would be a good time to not ask me. I'm going to go back to the main screen, take a couple of screenshots and post them, and then we will call it a day. Boom. Just drop a couple of these people over on the left so that we can see all of them. And just do a cut and paste. There we are. All right, now we'll pop back over into here and paste it in. Did some face tweaking to reduce the outrageous cartoonish stuff. Game dev. Screenshot Saturday, which is apparently also trending on Mastodon. Poof. No, that's not the right one. That's the right one. Doop and doop, and there we are. All right. See you folks around. I'll be back next Wednesday or next Saturday, roughly the same time, definitely the same channel. Have a nice night.